Okay, in this video, we are going to be doing Calc AB problem set number 14. There's a link to the problems in the description, as well as a link to a playlist of all the previous problem sets. I can never say that part. It drives me nuts. All right, let's take a look at the problems. Given v of t is equal to 5t to the fourth plus 3t squared plus 2t, and that x of 0 is equal to 6, find x of t by reversing the power rule. So, the power rule is bring the exponent down, and then subtract 1. To reverse that, we're going to have to add 1 to the exponent, right, because we subtracted 1. And then we're going to have to multiply by the reciprocal of the exponent to cancel out what happened when we brought the exponent down. So that's our goal. We're going to add 1, multiply by the reciprocal, plus 1 times the reciprocal. That's how I say it every time in my head. So I'm basically going to initially ignore the 5, 3, and 2, those coefficients. And I'm going to say that x of t is 5 times... I'm going to plus 1 to the exponent gives me 5, so 1/5 t to the 5th. 3, 1/3 t cubed, so plus 1 times the reciprocal. 2, 1/2 t squared, so it's plus 1 times the reciprocal. Then I run into this problem where the derivative of any constant at all, pick a constant, pi, e, the derivative is 0. So I have to just throw a plus c in there because I don't know if when I took the derivative, maybe there was something there and it went away. The way I'm going to solve for that c is I'm going to use the fact that x of 0 is equal to 6. So it is useful to simplify this first. So x of 0 is equal to 6. So I'm going to say 6 is equal to 0 plus 0 plus 0 plus c. So 6 is equal to c. And then I'm going to write my final answer as t to the 5th plus t cubed plus t squared plus 6. That is the idea. You're going to do that a million times in calculus. Let's do another one. Given v of t is t to the 4th plus t squared plus t, and that x of 0 is 9, find x of t by reversing the power rule. All right, same deal. Plus 1 times the reciprocal, plus 1 times the reciprocal, plus 1 times the reciprocal. You kind of chant it. It's not that bad. So plus 1 times the reciprocal, so get 5. Ooh, I messed up. I didn't plus 1 there. Plus 1 times the reciprocal. So I got to fix that, right? Ugh, I hate fixing things on the fly. Here goes. It's like, how big is my eraser? I don't know. Plus 1 times the reciprocal. There we go. Okay, we're back in business. Hopefully, put my stylus back. Now, we need to solve for that c value. So, again, we get 9 is 0 plus 0 plus 0 plus c. That's actually really common. You can't assume that's going to happen. We're going to run into the problem again with a 4 because I just copied it. We have this. So let me fix that exponent again. So it should really be, things happen, man, you know? Try to knock out these videos. I'm the only one looking at them until I post them, and then you can all critique them. There we go. 1/5 t to the 5th plus 1/3 t cubed plus 1/2 t squared plus 9. That's what we get. You know what we're doing? We're going to do another one. Because once you get this idea down, you want to practice it a lot. V of t is just 5. And x of 8 is equal to 3. So not x of 0 this time. X of 8 is equal to 3. But first, we're going to reverse the power rule. So, where does 5 come from? It's 5 times t to the 0, I guess you could say. So if we add 1 to 0, we get 1. The reciprocal 1 is 1. So it'd be 5 times 1 over 1 t to the first, so just 5t. Or you might look at that and you just think to yourself, 5 is the slope of 5t. That would be a great way to think about it. We throw in the plus c because we're not sure. We do know that x of 8 should be equal to 3. So that would be 3 is equal to 5 times 8 is 40 plus c. So that'll make c be negative 37. And then our function will be 5t minus 37. All right, let's do another problem. This problem, to me, initially, it looked like a nightmare. If dy dx is equal to, mostly because it was find the second derivative. And I was like, oh my God, that's going to be terrible. But we're given dy dx, so we're really just finding the derivative of this thing. We're not doing two derivatives. So dy dx is already 2x minus 5 squared, 3x plus 7 to the 5th. All right, so product rule with a little bit of chain rule involved. So we have dy dx. That's the thing to keep in mind. The second derivative, going to be first 2x minus 5 squared, derivative of the second, 5 times the thing to the 4th times the derivative of the thing, which is 3, plus second, which is 3x plus 7 to the 5th, times the derivative of the first. So it'll be 2 times the thing to the first times the derivative of the thing, which is just 2. All right, you look at this and you're like, oh, there's some common factors. I'm not going to make you watch that. So I took out the greatest common factor, which is 2x minus 5 to the first and 3x plus 7 to the fourth. That left me with 3 times 5 is 15 times 2x minus 5. And also, 2 times 2 is 4 times 3x plus 7. So that's what we had to deal with. I then, combined things to get this. And then I looked at that and I was like, this could be done, except there's definitely a 7 that I could take out. And I don't know why it looks classier if I do that. So I took out a 7 and I got that as my final answer. All right, that's the problem set. I hope you found this helpful and good luck.